Figure it out. Sort yourself out. That's a mess. Where's my pen? This is where we're going to figure out where are the rest of those things. Now, we talked about how, where's my pen? We talked about how there's about 50 things we're going to put on the, did I drop the pen? Oh, here it is. I got it. We talked about how there's about 50 things we want to learn on the unit circle test quiz. Yesterday, we learned about 20 of them. You already know about 10 of them. And so this is where we're going to get those last 20 things. Intro continued. For the unit circle, the three basic trig functions are defined as, we did this yesterday, sine is which letter? Y. Whoa, gosh, not off to a good start, Mr. Collier. Y. Cosine is? And tangent is? All right, tangent is really probably the one we need to remember. We also talked about this from yesterday. This looks like a nice, perfect 45-degree angle that goes perfectly through the corner there. What are the x and y values of a 45-degree reference angle? Square root 2 over 2 and square root 2 over 2. Now, if you remember yesterday, we did those notes. We came up with square root 2 over 2, and I was kind of like doing some math. And some of us were thinking, I don't know what he's doing here. I'm getting lost. But then at the end, I was like, scribble all this out. You know what? You don't need to know any of that. You just have to memorize this, square root 2 over 2, right? So we're going to do kind of the same thing again today. We're going to discover those numbers. And then the reality is you don't really need to know where they came from, but you do have to memorize what the actual numbers are. So here's the discovery part. This is probably the most confusing part of the notes. And in the long run, this is going to help you, but it's not mega necessary. 30, 60, 90 triangles, okay? We know that a right triangle, and I wouldn't write this necessarily, a right triangle that is 45, 45, it's just nice, right? It's just nice and balanced. It is an isosceles triangle. It is nice and balanced. We love that, right? Great. Well, what other triangle is just nice, right? The other triangle that's really nice is a 60, 60, 60 triangle. Now, again, you don't necessarily need to write that down just yet, but a 60, 60, 60 equilateral, equiangular triangle, that's also just kind of nice, right? It's a perfect little triangle. It just mathematically satisfying, I guess. Now, for our 60, 60, 60 triangle, it's not a right triangle though. And so all of our sine, cosine, tangent stuff that works with right triangles doesn't really work on this triangle, which is a 60, 60, 60 triangle. So what they do is they take that 60, 60, 60 triangle and they draw this line across the middle. And they cut it into two equal triangles, a top half and a bottom half. Now, when they do that and they cut it perfectly in half, we're gonna get a 90 degree in that corner and a 90 degree in that corner. Did we mess with the top corner at all? No. It's still 60. Did we mess with the bottom corner at all? No, it's still 60. But we did mess with this left corner. There's a fancy geometry word that starts with the letter B. What do we do to that angle? Yes, we bisected this angle. We just chopped it in half. And so what do you get when you chop 60 in half? 30 and 30. All right, now that is where the 30, 60, 90 triangle comes from. It is also just kind of nice, right? It's not quite as nice as a 45, 45, 90, where you got two sides, or two angles and two sides that are perfectly equal, but a 30, 60, 90 also just has like a nice little harmony to it. Now, all that being said, we don't really need two of the triangle, we only really need one of the triangle. So here we are, a nice 30, 60, 90 triangle. That's going to help us with any angle that is a 30-degree angle or any angle that is a 60-degree angle. So let's figure out those measures. Now, this side, if we're on the unit circle, that side looks like our radius. So what is the radius of the unit circle? 1. What would the what would the length of this side be? It used to be 1, but then it got chopped in half. So now it's a half. And what about this bottom side? How long is that line? Well, it's not really related to the outside because it's a line. So honestly, I don't know what that side is, and we'd have to do the Pythagorean theorem. Okay? Now, Pythagorean theorem is not hard. Do we want to do the Pythagorean theorem of a 1/2? And do a squared plus b squared, except for one of those is a fraction. That sounds kind of gross. So here's kind of the strangest part. In order to avoid that, in order to avoid this fraction, we're just going to make this twice as big. If we make this twice as big, instead of 1/2, twice as big, what would that be? 1. And if we take our 1 and we make it twice as big, what would it be now? 2. This is a lot easier. We can do Pythagorean theorem with this stuff, right? I mean, 2's and 1's. That's way better than having to do it with a 1/2. So let's do the Pythagorean theorem. A squared plus b squared equals c squared. We're missing 1. This piece down here, we can call this x or something. Is x an AB piece or a C piece?
AB.
It has to be an AB because C has to be the hypotenuse and 2 is a okay, so let's put the 2 here. We can put the x here. That's what we're looking for. Let's put the 1 here. And this should be really easy to solve. X squared equals, what is 1 squared? 1. What is 2 squared? 4. And when we subtract the 1 over to the other side, what is 4 minus 1? 3. Square root both sides? The square root of 3. All right, we have figured out now that our nice 30, 60, 90 triangle has a hypotenuse of 2, an opposite of 1, and an adjacent of the square root of 3. Now that square root of 3 is a little bit funky, but the other two sides are so nice and boring and easy, it's not too bad. Okay, now let's actually figure out, this right here is our 30 degrees. Let's say our guy or girl is standing right here in this corner, okay? What would the sine of this triangle be? Opposite over hypotenuse. 1/2. And does that sine go into the x position or the y position? The y position. All right, if you've been snoozing a bit, if this was all crazy, and you know what, it wasn't too bad today, but it was a little crazy. Time to wake back up again. The sine of 30 is 1/2. Now, that's pretty nice. That's not a number like square root 2 over 2. It's just 1/2. That's it. So that's not too bad. Now, what would the cosine of 30 be? Square root 3 over 2. Square root 3 over 2. All right, we learned the angle measures and the values that you're given, the x and y values, for a 45-degree reference angle. Here is for a 30-degree reference angle. It is square root of 3 over 2 in the x position, and it is 1 over 2 in the y position. Now, that would work for all of these. This is 30 degrees. Over here, this one would be 150 degrees, right? A 30-degree reference angle, 150. And that's going to have the same exact numbers. Square root 3 over 2, 1 over 2. What degree measure would this be here? 30-degree reference angle, but in the third quadrant. 210. 210. Because it's 30 degrees past the 180. Right? We're working with 30 degrees here. 30 degrees, and that's going to have the same exact thing. Square root 3 over 2, 1/2. Now, remember, we're learning basically part 2 for yesterday's lesson. And I know yesterday's lesson felt like alien math for about 20 minutes, but then all of a sudden, okay, you know what, it's not too bad. Okay, it's very similar. You got to just stay with me, stay with me. And same thing over here. What angle is that? It's 30 degrees away from 360, so it's 330. And it has the same exact numbers. Square root 3 over 2, 1/2. So there's 4 positions around the circle where we have those same exact numbers, square root 3 over 2 and 1/2. We're missing the signs, so let's make sure we put the signs in there, right? It's the same for, in the second quadrant, the x is negative. In the third quadrant, they are both negative. I'll do it like this so we can see it extra good. And in the fourth quadrant, which one's negative? The y. Now, the only thing we're going to do, and then we have basically learned everything today. Last thing we want to do is figure out our radian measures for these. Right? We know that it's 45 degrees, which is the same as pi over 4. Okay? Well, how do we talk about 30 degrees in radians? If we don't know, we can convert it. 30 degrees times, are we putting the 180 on the top or the 180 on the bottom? The 180 on the bottom, so that the degrees will cancel out and it will give us a pi. Can somebody type that in the calculator without the pi, remember? What do we get? It's really easy, really simple. 1 over 6. 1 over 6 pi. Yep, this is pi sixths. Over in the second quadrant, it's going to be 5 pi sixths because we're 1 little sixths away from being 6 out of 6. What would it going to be in the next third quadrant? 7, right, because we've got 1 too many sixths. And then what's it going to be in that fourth quadrant? We almost are reaching 2 pi. We almost are reaching 12 out of 6. 11 out of 6. Just one short. Just one short. All right. Now, for a second, you were probably thinking, square root 3 over 2 is going to be really hard to memorize, and I have to focus. That's what I need to learn today. The reality is, square root 3 over 2, you're going to learn very fast. It probably doesn't feel like it, but you will learn square root 3 over 2 a lot faster than you think. It is these that is probably going to be the hard part for you to memorize. Okay? We're talking about sixths because 30 degrees is 1/6 of a pi, and we have 1 more than 0, 1 short of being 6 out of 6, 1 extra of being 6 out of 6, and then we are 1 short of being 12 out of 6. All right, let's do some questions here. Find the exact value of these things. The cosine of 150, 150 is over here in the second quadrant. 150 is a 30-degree reference angle, which we just learned, which is, parentheses, square root 3 over 2 in the x position and 1/2 in the y position. In the second quadrant, the x is negative. Okay, what is the cosine of this? It's very easy. Cosine is the x So grab the x and you're done. What's the answer? Negative square root 3 over 2, done. That's the whole question. We got it. The sine of 330. Okay, well 330 is in the fourth quadrant where we have the exact same thing. Grab the y value. Is that the square root 3 part or the 1 part? That would be 1 over 2 for the sine piece. But just be careful. In the fourth quadrant, is sine positive or negative? Negative. You're correct. Again, remember yesterday when it was like, this is really hard. Wait a second. Every question is answered square root 2 over 2. It's kind of the same thing. This is hard. Wait a second. All the answers are just square root 3 over 2 or 1/2. And that's why today's a little bit harder, because instead of getting one option, you have two options. Sine of pi over 6. What is pi over 6? Pi over 6 is 30 degrees. Pi over 6 is quadrant 1. Quadrant 1 means everything's positive. Just grab the sine value, grab the y value, and go. 1/2, we're out of here. Negative 5 pi over 6. Go backwards, this direction. I'm almost getting to 6 out of 6, so I'm going to stop early here in the third quadrant. In the third quadrant, everything's negative. Grab the cosine and get out. And the last one, 19, seriously, gross. Well, if it's 19 pi sixths, you can do it with your loops or you can do it with coterminal. It's up to you. If you like to do the spatial drawing, graphing, 0, 6, 12, 18, so 0 and then 6 out of 6 and then 12 out of 6 and then 18 out of 6 and then 19 would be right here. If spatially that's how you like to do it, great. If that doesn't work, then do it like this. Coterminal angles. 19 pi over 6, take away 12 out of 6, because that's 2 pi, so we double it on the top. And 19 minus 12 is 7. So really this question wants to know 7 pi over 6. We know that. 7 pi over 6 is right here. The sine is the y value, which is 1/2. And in the third quadrant, everything is negative. Was this one also here? I think I've left off a negative for that question. Okay, the very last thing is that the tangent, we haven't discussed yet, which requires us to put one on top of the other. The tangent requires us to put the y on top of the x. Now let's think for a second about how this fraction is going to work, because it's not as nice as it was yesterday, right? Yesterday, the tangent was square root 2 over 2. Here we go, white please. Square root 2 over 2 divided by square root 2 over 2. It's the same thing, it's 1. Today, we're not quite as lucky. Today, it's square root 3 over 2, 1 over 2. Those are not the exact same numbers. Bummer, okay? But it is still not insanely hard. Let's think about our rules of fractions. You've seen questions like this in Algebra 2. I promise you have. The top number is divided by the bottom number. So you could write it like this, square root 3 over 2 divided by the bottom number. And how do you do dividing fractions? Keep, change, flip. Square root 3 over 2, keep, change, flip, change it, flip it. And I'll be honest, if we had to do this for every single question, this is gonna suck really bad. But look at this. What is gonna happen to the 2's when we do this? They're gonna cancel out. We have a 2 on the top, we have a 2 on the bottom. The 2's are gonna cancel out. And so, we're gonna have square root 3 over 1. And do we really need the 1? No. Square root 3. Okay. So here's what's gonna happen. When you go to look at the tangent, okay? This is, again, if you're snoozing on me a bit, I know I keep saying this, stay with me. The tangent, when you look at these two, square root 3 over 2 and 1/2, the 2's never make it to the tangent. Because when we try to do the tangent, the 2's keep, change, flip, cross them off, the 2's go away. So when you're trying to do the tangent, you don't need to consider the 2's. You just consider the numerators, okay? For this, the tangent value would be the y over the x, which would be 1 over square root 3. And from here, we would want to maybe rationalize and have square root 3 over 3 as our tangent value. Our cotangent value, which would be the other way around, would end up with our answer being square root 3. But I guess for this front of the paper, it's going to be square root 3 over 3. Okay, again, if that sounds like the craziest thing ever, you got to give me, 5 minutes of doing these questions, and all of a sudden, it's not going to feel too bad. 330 is right here in this position. All right? And in this position, when we go to do tangents, we want to do the y divided by the x. But those 2 values, they don't even make it to the tangent. Only the top numbers make it. And so that would be a 1 over a square root of 3. And there's a negative sign, so it would be negative. If we wanted to make it look as good as possible, rationalize the fraction. There we go, negative square root of 3 over 3. Pi over 6, it's the same thing. Pi over 6 is in this position. Pi over 6 means take the y over the x, which is 1 over square root 3, which is square root 3 over 3. Again, the answers are surprisingly more repetitive than you think they're going to be. Okay. Here's where we're at. We have a unit circle. And our unit circle, we know about 0 degrees, about 180 degrees, or 0 and pi. We know about 90 degrees, and we know about 270 degrees. And yesterday we learned about 45, and we learned about 45, and we learned about 45, and we learned about 45. And what we just learned was about 30. And this one, which is also reference angle 30, which is 150. And we learned about 210. And we learned about 330. So what we've done so far is learned a lot and started to memorize a lot of different values around the unit circle. There's one more that we need to learn. Once we learn this last thing, we are doing some legit trig, okay? Until you memorize the unit circle, you're just a wannabe trig student. So let's flip this paper over. Here we are. The good news, it's going to take us about 1/4 the amount of time. What we did before was a, come on, here we go. What we did before was a 30, 60, 90 triangle. What we're going to do now on the back is a 30, 60, 90 triangle, the exact same triangle. So why are we doing the exact same triangle on the front and the back? What if you spin the triangle? What if our little dude is standing at 60 instead of standing at 90? Well, those numbers that we had from before, which were 2, 30. I'm trying to make sure they're in the right position. There we go. Spin the triangle. That's right. Now, if we're in this position, we're going to put this all together and we're going to figure out what are these going to be. But here's the good news. It's the same triangle. It's the same numbers again. So it's not going to look brand new. It's just going to look a little new. In this triangle, with our person standing in this position, what would the value of cosine be? Adjacent over hypotenuse. 1/2, which means the 1/2 goes in the x position. And how is that different from the front? On the front, the 1/2 was in the y position. Now, it's in the x position. What would the sign be? It would be square root 3 over 2. And for all of these values, it's the exact same thing. 1/2 in the x position, 1/2 in the x position, 1/2 in the x position. Square root 3 over 2 in the y, square root 3 over 2 in the y, square root 3 over 2 in the y. Exactly like the front, except for they're in different spots. We still need to make sure we get our negatives. A negative x, a negative both, and a negative y. Those negatives are very important. What are these values? This is 60 degrees. This is 120 degrees. This is 240 degrees. And this is 300 degrees. I'm going a little bit fast because I know I feel like we're getting a little math burnt out here, and I understand that. Those numbers are not that hard to come up with though. We're going with 60, and then 60, and then 60, and then 60. That's how we're getting these numbers. This is 180 minus 60. This is 180 plus 60. This is 360 minus 60. And the last thing is the radians, which again, we already know how to convert these, so you could find these on your own, but I'll help you by telling you. This is going to be pi thirds. And think about it. This is a third of the top. Right? We got a 1/3 of cheese right here, and then we got 1/3 of black cheese in the middle, which sounds gross, I guess. And then we have one more third over here. So that's 1/3. This is going to be 2/3, 3/3. We're going to skip 3/3. Then we've got 4/3. Then we've got 5/3. And 6/3. That's the whole 2 pi. I'm going to leave that behind. All right. We're doing great. Here we go. What is the cosine of 300? Go to 300 degrees, grab the cosine. 1/2. Done. Question's over. What is the sine of negative 2 pi thirds? What do you say? Yep. Does anybody have the answer for the second one? Sine of negative 2 pi thirds. Negative 3 square root of 2? You're exactly right. How did they do that so fast? Well, negative 2/3 is -1, -2. That's right here in the third quadrant. Okay, in the third quadrant, all we have to do is grab the sine value, which means grab the y value, which is right here. We grab it, and the question's over. Nice job. The next one, which says 8 pi thirds. A very similar answer. We heard, you said what? you just word square root 3 over 2. You know what you're doing. You just said the words in the backwards order. You're totally fine. How do we get this? Where the heck did this come from? If you don't like doing the count it by the loop stuff, use your coterminal angles. 8 pi thirds is too big, so take away 6 pi thirds, because that's 2 pi. That's just a double on the top. And what's 8 minus 6? It's 2. So what we're looking for is 2 pi thirds. Here's 2 pi thirds. The question asks you about the sign. So grab the sign, 3 pi halves. Tangent, we finish this up on the front by talking about tangent. The tangent of 120, okay? 120 is in this second quadrant. Tangent means divide the y with the x. But remember, the 2's never survive when it comes to the tangent, because the 2's are on both and the 2's cross off. So we're going to grab the y and divide it by the x, which is square root of 3 divided by negative 1. The answer here is going to be negative square root of 3. What about the tangent of 2 pi thirds? That's just, what a dumb question. Who made this worksheet? Same exact thing. All right. Deep breath. Deep breath.